Hi, I'm Drew. What we're going to do today is go through a bit of a forensic teardown of a battery which has failed. This battery was manufactured by DCS. It was provided to me open, so I can't vouch for the internal structure of it, what was there, what wasn't when it originally started. It looks like it hasn't been modified or tampered with. But that being said, I've actually got a second DCS battery which has failed, but hasn't been opened. So we'll conduct a full teardown of that one in a future video. Normally I don't like to do this type of thing. I really enjoy engineering and I like looking at the good parts of that type of stuff. But in this case, I got into it in the first place just because I was interested, and it looks like there are some design issues in the battery which could result in things like wires being exposed to fusing currents, things like that. And what that means is that there may be materials inside of the battery, inside of the housing, which could end up reaching 1,000 degrees and acting like an ignition wire for a pyrotechnic fuse or something like that. That was a real concern to me. Obviously, like I said earlier, I got it opened, so I don't know if this was the condition in which it was originally provided, but I have another battery, so I'll open that one in a future video. The other thing is, when I received this battery, I got it from a person who asked me to sort of look at it, but not necessarily tear it all the way down. So what I've done is I've done an incomplete teardown, and that's this video that's coming up. I've since gotten permission to go through that process and actually get into, individual cell structures, pull the boards apart, take a look at individual components of the board as well. So I think that'll be really interesting. It's a bit frustrating that there are these concerns around the safety of this battery, but I think it's interesting just to take everybody through this. And what I'll be throwing up on the screen are basically standards data that tells you, where these things, where these limits are, that sort of stuff. Generally, I don't like leaning on, sort of qualifications and experience. I like to think that knowledge stands on its own. But given the sort of the seriousness of this sort of stuff, it's probably worth me giving, at least a little bit of my background. I've worked in mechanical engineering for coming up on 20 years. I started in manufacturing, but very early on left that and moved into defense automotive. And so in that intervening time, I've done a bunch of electrical installations, mechanical installations, designed a whole bunch of different systems, worked in cross-functional teams. I've also conducted investigations on behalf of a number of organizations, appeared as an expert on behalf of a number of organizations, and I've been asked to provide advice to a coroner on one case with a vehicle. So anyway, I'm keen to jump on with the video, and so what we'll do is just go back to what I'd originally recorded. Thanks. Good. I thought this would be a really interesting one just to work through from a mechanical engineering point of view. I've had somebody volunteer to give me one of these DCS batteries to go through and have a look at the mechanical environmental aspects of it. I'm not an electrical engineer, I'm a mechanical engineer, and so I'm not going to comment on the details of, sort of electrical stuff, that sort of thing, or maybe I am, but if I do, just put that little asterisk after it for me, so yeah. In terms of the mechanical stuff, it will be interesting to look at this in terms of vibration isolation, strain isolation, things like that. The fellow who gave this battery to me had already opened it, and all the cells are dead. I've already confirmed that, but I'll go through the voltages and check just to make 100% sure. I think it's really interesting to get into these things, recognize that obviously as it's been open, I can't guarantee that any of this is as DCS would have left it, but I think treating it as a general exercise in what to do, what not to do, I think that's part of what would make this interesting for me anyway. So I'll get an overhead camera set up and we'll crack into this from, see how we look. Rightio, so looking from the top, we can see it looks pretty well like you'd expect. You've got basically isolated terminals here, or they look like they're at least heat welded in. These are screw threaded. You can see that there's some sort of break in this here. It might be because it's a repurposed lead acid battery with separation for individual cells, and therefore there may be filling ports under here that haven't been opened. We'll crack it open and find out. So this is the underside, and yeah, it looks like this is a repurposed lead acid battery container. The first thing I can see here is that there's not a lot of strain relief for these wires now directed into corners. These were left in the box, so I don't know where these were originally placed. I assume these were the original vibration isolation. If they were, it's inadequate. If they weren't, then good. This is the battery control circuitry, BMS. You can see that's ground isolated here with 3 separate strings. And you can see that corresponds to 3 wires coming out of here. On this side, you can see the 3 power wires are directly connected. Something that's interesting from the point of view of battery design is this is obviously taped on. There will be a little bit of lateral play. With any battery cell, they do need to be vibration isolated against the sides, so you need physical isolation here, separation. And the reason for that is because you'll eventually start suffering fatigue over time. That also needs to be considered when you look at wire routing and strain relief as well. When you look at these are really interesting. When you look at these are a really interesting one up here. What you'll see is that they're heat shrunk as a group. All 3 wires have been crimped into one tab. At the moment, we're just seeing a heat rating and a weight. We can compare the 3 of those to the on the top amp hour rating. And that's a good way to look into this as well. These are probably not a chassis wiring type of thing, but again, not an electrical engineer. This board here is interposed to insulate this board from this board. I don't know if this was originally fiber taped. If it was, that's a little scary because this will be subject to fatigue. When you get into this as well, the other thing is running hot and ground next to each other, especially over things like this, can really put your system at risk, because if this exercise is subject to vibration, what you can find is that sharp edges or components on this board, anything can work through, and you've got live from the cells. We'll find out later if these are actually fused, but these are balance lines or sense lines. So whatever this is, it turns into a high current fuse instead of a wire over time if we're not careful. We'll investigate what these wires are as well. These feel like silicon. These feel like silicon. These feel like they're PVC. Looks like we've got a silicon wire here again. Silicon wire. And then this appears to be a data communications port. These feel like they've got a PVC or some other hard type of plastic coating. But the other thing is, it doesn't look like there's been anything to actually retain this here. It might have been under the tape originally, but interesting, eh? What we'll do is we'll get rid of all of this. I've already established that the voltage in the cells is below 1 volt. So the battery's functionally dead. This is also isolated, so the BMS has cut the whole exercise off. Next step is to crack on into it. Rightio, so I've just lifted the top on the battery. You can see here, these are potted and isolated terminals, so that's good. You can see the screw type. As I've said previously, this wasn't provided to me sealed. I haven't opened it, and I've been told that it's been resealed, so I can't really comment on the top environmental protection. When we flip this over, this is a bit of a concern. So when you can see that one wire is shorter or longer than the others, what you'll tend to find is that this will be the first wire to fail if you expose the whole exercise to vibration. So that's a bit interesting. This is what I was talking about before. So this is your 1, 2, 3, 4, 5, 6 2-volt cells that you typically find on a lead acid battery. These are what you'd normally expect when you're looking at a lead acid system. This is a single screw terminal with a crimp finish here. These are single wall heat shrink, and it doesn't look like it's actually even completely shrunk down onto the wire. So this won't offer any significant strain relief. The cable is crimped as a group under here. I won't cut the crimp open to make sure that they've got good crimping, but normally what you'd do is a pull test on the wire when you're crimping. And the other thing you'd expect is that crimps depend on plastically deforming each of the wire strands so that they all weld together as one, or weld together as one. So that's pretty critical there. This looks like this is potted in reasonably well, so that's not terrible. I don't know what's going on here. That's a bit of a weird one. I don't know whether that was done before or after the battery was assembled and shipped, but yeah, that is a bit strange. So if I flip that out of the way for the moment, This is what we were talking about before. So we've got a communications port here, or what looks like a communications port here. This is a good connector type, quite like those. It's capable of carrying quite a lot more current than they'd need for the communications. You can see they're attached here. They've put dobs of silicon on top of each of these communication ports, which is a little weird. The other thing that you can see pretty prevalently here, actually, I'll get rid of this. So just to start, when we're working through these types of things, normally what you'd expect when you look at this type of thing is that there would be some form of either mechanical connection, because mechanical connections tend not to suffer the same vibration sensitivity as a solder, or alternately, what you should see is some form of strain relief. It may have been there and been removed, but at the moment that's quite a sharp, hard-formed bend straight down the side of the pack. Normally what you'll find is that solder will wick up the wire, and so you'll get a varying stiffness as all of those wires variably bond together up the length of the wire. So it looks like we've got this little fella here running to each of the board wires. You can see here where this wire's copped a bit of a hiding at some point in its life. Can't tell when that is. What else have we got? Well, this may actually be active balancing. What have we got? Okay, this is on standoffs. Oh, that's better. Okay, so that's pinned in with cable ties. So there are small cable ties holding this board on here. It looks like it's been siliconed on the edges for vibration isolation, so that's okay. These look like these are screw standoffs on top of the battery. That's okay too. So can we move that board? No, that's fairly well nailed down, that's all right. So this tape appears to go between these two, so I can pull this out of the way, have a quick look here. And then this is already back, although we have ground wires sandwiched between two layers of tape. Let's find out what's holding this thing on. Tape and this wire, apparently. So you can see here, when you move this board up and down, you can see that the motion of this board has actually been quite heavily restrained by this wire, and that's because the solder's wicked back. It's made it quite a lot stiffer, and I expect I'll find that it's soldered onto something down here. So this wire's been turned into something more like a solid core, whereas you can see these other wires are a bit more flexible, although these would still be subject to fatigue in this area here where they've been quite hard formed. All wires will have a minimum bend radius that you typically expect to be respected. In the case of things like this, silicon wires, typically they've got quite a lot of fiber in them, as well as the silicon insulative jacket, and so they tend to be a bit easier to bend around a corner. You can see here, because this comes off parallel to the edge, and when you pop this down, you either need to bend this back like this to get an appropriate bend radius in it, in which case you've got it vibrating over two sharp edges, although at least this is ground. That would potentially allow ground leakage to bypass the BMS here and isolator. So all these other little fellows here, this is a real concern. So this is one of the balance leads, or balance or sense leads, I'd have to work that out. But balance or sense, this is one of those leads. This is actually routed under the board. And over this way, it looks like there's a paper and a foam pad, which is maybe isolating that, I'm not sure. Okay, let's try and get this out of here. Right, so you can see here, we've now got the top out of the way, or got the sides out of the way, I should say. There we go. Rightio, so you can see here, we've just got it out of the box now. I will do that voltage check again just to be 100% sure. Make sure that the battery hasn't miraculously healed itself. Right, so I'm getting 4.2 across all four cells together. So, right. So, just grab this off, and so I have 1 volt on cell 1. Now, come on, there we go. 1 volt on cell set 2, 1 volt on cell set 3, and 1 volt on cell set 4. So this is done. So I guess this is sort of built in place. So what have we got under here? 2 pods of sticky foam. That's about it. Right, so with this little fellow, it doesn't look like there's any evidence that this has actually been retained by anything. There's a little bit of maybe residual texture on here indicating maybe there was more tape on it at one point. But these board edges are usually quite sharp, so running any sort of wiring in an uncontrolled way over the top of them is really asking for trouble. You can see here how these have been quite sharply bent. I feel quite uncomfortable with that. I certainly wouldn't do that myself. This is quite good. This is basically adhered down ground, but the concern here would be that it then snakes over or goes under one, over the top, and then under the third, over to this port here. So a lot of this looks like it's been sort of kludged together, I guess. It's a bit odd. You can see up these wires here. Oh, it's quite mobile. What's going on there? Okay, so there's an electrical strip here, and that looks like that's spot welded to some stuff up here, to guess. Let's have a look under that. I'm a bit hesitant to cut these wires because this was given to me, and I do want to actually ask whether the person who donated it wants it back, I guess. So yeah, I don't want to go destroying anybody else's stuff until I've got a very explicit approval to do that. Yeah, you can see here these wires look a bit tortured. They've taken a permanent set. We will try and get some imagery later to find out what these are, but I'm guessing that these will be 200 degree silicon again. Same thing as we were talking about before. One of these wires is a lot shorter than the other ones, or has a lot longer path to go than the other ones. So you would expect in that type of application that this little fella will fail before all these other wires, just as that sort of stuff. You'll also see that this hot wire is going straight over a ground, so this is a potential source for fire because you would have a sharp board edge here. When this is plugged in, what you'll see is these wires appear to have been routed straight past this exposed terminal. It doesn't look like there's any conformal coating on this, certainly no potting. So this doesn't look like it's been designed to be environmentally protected at all. If we pop this up on its edge, so I'm not going to damage anything. No, good. So if we flip this up on its edge, we can see this tab and heatsink isn't a bad setup at all there. So that's quite nice. I like that. That's well strain relieved. It looks like they've got a similar setup there, so that's nicely set up. If I flip these up here, I won't further disassemble this or pull the tape to pieces. It looks like it's got fiberboard on the top to insulate it. That looks quite good. Hopefully the edges are protected from the cells. It looks like they are by the weld plate. So this is a spot welded plate which attaches each of the batteries on. Again, I'm a mechanical engineer and I haven't done professional pack design before, but it doesn't look like there's a lot of indentment on the spot welds, frankly. It'd be interesting to get somebody's opinion on that, but that's not me. I do like the cell isolation here, so gridding up like this is really nice. That protects them really nicely when you assemble them together. So the cells here are labeled DCS engineering, 7.2 amp hour, 210501. Okay, so that makes them about 4 and a bit years old, 3 and a bit years old. Taped on the end, that's good. Now the interesting thing with these types of things is There are very few cell manufacturers in the world. A lot of people rebrand other people's cells or alternately assemble cells into packs, so it's extremely rare to find a primary or secondary cell manufacturer like this. That would make me suspect strongly that these are rebranded or relabeled cells. It would not be odd at all to see that. Normally, these things are huge plants to make these, and so it would be really rare to expect to see anybody who's not a major battery manufacturer making their own cells. How much effort it would be to pull a cell out of this. I will have to ask as to whether I can actually fully harvest this battery. Oh shit. That's an interesting one. There's nothing in the bottom of this. So that means either one or another of these pads or something like it must have been sitting in the bottom previously, or alternately this was never properly isolated from the bottom of the battery, which is interesting. That looks like remnants of adhesive. No. Yes. Yeah, so that's remnants of adhesive there. Where would that have come from? Must have been on the side of a pad. There's been a kink in the wire there. But because this has been disassembled once before, it does make it hard to attribute damage if there is any. These types of foam isolator are pretty iffy. You definitely want to select an appropriate density of foam and then fully encase it. And it doesn't look like there is any meaningful environmental protection in the battery. Normally you'd expect some form of conformal coating, potting, something like that to protect all this stuff. With these wires, what you'll see frequently is, if I can isolate this, you can see if I lift it up, it doesn't want to bend through this segment, and that's because solder's wicked up here. So what you'll find is that while it's quite flexible up here, as you get closer to this, it gets less and less flexible, and that's because of the solder wicking and stiffening the wire. And that that's bad practice for automotive. You'll typically see that will result in fractures in the wire cores up in this region, which will be resultant from fatigue, vibration, and that's typical for what you would expect for operating a car, something like that. Yeah, so I think that's really interesting in terms of the mechanical packaging. Don't like that wires appear to be randomly snaking everywhere here. This actually appears to be over two sharp edges. There's one sharp edge here, and then obviously the one under the board on the ground on the other side. This really isn't much of anything in terms of strain relief. This would normally, at the very minimum, I would expect this to be glued heat shrink. So effectively double adhesive loaded, and that is a lot stiffer and allows the wire to have that strain relief and to put strain back on the jacket. I'm not lucky to knock my coffee over there, it would have been very sad. Yeah, so I think I'll get permission from the owner and see about whether or not we can do a further disassembly of this thing.